Joel, whenever you're ready.
Okay, well, welcome everybody. This is the last session of N3C Community Forum Classic. And we're moving on to N3C Community Forum New, Generalized. I'm not sure actually what we're calling it. Next slide, please. So, okay, so the usual things. Now we have a deep understanding of a chat versus Q&A. And you can use either, whatever is working and whatever you're inspired to do, and you can raise your hand if you want. Next, okay, so there is a expansion to from COVID focused topics to a broader range of topics, including real world data analytics, which I think is a great idea. And I think and it'll also be bi-weekly, Mondays at 5 p.m. With a new Zoom host. And I guess new attendees will be moved to new Zoom. Registered attendees will receive an email. So I think it's really still a work in progress to find the good exemplars, of which there are many, of real world data analytic projects. So I think this is a great idea. Real world data analytics is a really important area. And certainly, our group has interests in lots of real world data analytics, which include, but certainly are not limited to COVID. And I think that's probably at this point the case with a large number of people. So I think this really will serve a really good purpose. So we're interested in suggestions and people who groups who want to present. Next slide, please. Oh, okay. So, and there's a bit.ly. You go back for a sec. There's a link, forum feedback to provide that, or can send messages to any number of the people who are typically involved in this as well. Melissa, myself, there's lots of us. But it looks like the N3C Forum feedback is a good focused way of doing that. Next slide, please. So, Brad Malin is on today, and he always has really interesting things to say, and I'm sure there'll be a lot of great discussion. March 13th, site report cards, data quality reports for sites. March 27th, R3 talks by Melissa Handel and Emily Flaff. And April 10th, the future and role of cancer data semantics, which I guess is definitely a nice demonstration of the generalized nature of this. And so this is very exciting. I think I'll probably sign up for a talk myself, talking about some of our work, and I encourage other people as well. Next slide, please. Okay, so we have 7.15 million COVID positive cases, 18.2 million people. So things continue to grow. So next slide, please. So Brad will be talking about de-identification methods, considerations for ethical AI and data distribution, and certainly during the life of the consortium, I've had lots of interesting discussions, probably a little earlier in the pandemic with Brad on some of these things, and I'm sure other people have as well. So he always has great insights. So Brad, over to you.
All right, thanks, Joel. Let me share my screen. Not that one. Okay, can you see it?
Yep.
Great. Okay, so it's really great to see people who I know in the audience. So I am more than happy to take questions as they come along. I'm not going to be paying attention to the chat, so if somebody wants to bark them out as I'm going along, that would be fine. All right, so what are we going to talk about today? First thing first, I'm going to jump right in and say, why are we talking about this in the context of COVID? So we wrote a paper that came out, I guess, a couple months ago now, that talked about how adversarial assumptions influence re-identification risks and how this affected COVID data sharing or the potential for the re-identification of COVID patients in the state of Florida. And so this was a paper that talked about how exactly re-identification could occur and what organizations how they were going to try and assess whether or not they needed to worry about these types of risks. I'm not going to go through this too much at the moment because I want to give you more of an introduction into why we're even talking about this or how we got here. Okay, so I've asked to talk a bit about de-identification. And one of the things that keeps coming up with de-identification is, when does this happen? Who's actually doing this? And I think it's probably more common than you might think. And so there's a number of organizations, I would say non-for-profits, government agencies, companies, both in the US and abroad, that apply the principle of de-identification. Now, why are they doing this? Some are doing it to support real-world evidence investigations. Some are doing this when they want to publish clinical trials data. Others are doing it when they want to share data for software development. And there's a number of other use cases that you can imagine. All right, a couple of examples of where this has been applied in principle. So some of you may be familiar with IBM's market scan claims database. This is an example of where you've got over 200 million individuals' insurance claims that have been put together, and IBM licenses this for research purposes. Another one is the ASCO Cancer Data Link or Cancer Link. And so in CancerLink, this is a point where they have collected lots of data on cancer patients and their experience and trajectory over time. And so ASCO makes this available also in a de-identified manner. The All of Us research program is probably something that you're familiar with. This is what I've spent a lot of time working on for the last couple of years. And at All of Us, we did de-identification, but we did it on a bit of a more grandiose scale. And so what do I mean is that we've created tiers with respect to access. And so in one level, we've created a public tier. And in this situation, the data can be accessed without logging in, and we give access to summary statistics. We then have architected 2 sandbox environments where we allow researchers to come in, and all the data is hosted on GCP, and we've put Terra on top of this and Jupyter Notebooks on top of Terra. And at one level, we've created what's called the registered tier. And this is available to anyone within a trusted academic organization at the moment who proves their identity and enters into a use agreement with us. And in the future, we're anticipating that this is going to expand to citizen scientists and people in industry. And we've shown that the data that we've put in this environment is subject to a very low risk of re-identification. We then have a controlled tier, and this is where, again, it's going to only be trusted investigators. But this is where we put genomic data in a lot more detail with respect to geographic information of where the patients or participants of this program reside. And so there's a greater amount of risk. So, but all of these are considered to be non-human subjects environments. So if you want to give a little bit more intuition into what we're doing, this is an example of what the data browser looks like over at All of Us. You have the ability to look at univariate statistics with respect to an individual's set of conditions or what conditions look like in the program, how many drug exposures we have and what they are, labs and measurements, and the list goes on. If you drill down, if you really want to see this, this is where you get to see the statistics that we're reporting. And one of the things that we've done is that we report on counts of multiples of 20. And so we don't allow for exact counts to go out the door out into the public domain. But given the volume of information that we're sharing, we found that this was a fair and reasonable approach to sharing the information publicly. Okay, so this is what's going on in the U.S. to a certain degree. I'll dig into like how methodologies work in a moment, but I still wanted to give you a little bit of a flavor to what's going on around the world as well. So in Europe, for instance, the European Medicines Agency brought forward Policy 70, and under Policy 70, this is a push to publicly disseminate clinical trials data. And they're currently in phase 1, which is publication of clinical study reports, but they're moving towards the publication of individual level records. So this is not something that we do over at the FDA, and so Europe is kind of taking the first plunge off of the cliff at this point. Okay, so this is an example of just what's going on. In all of us, I get the question all the time, like, so what's in the registered tier, what's in the controlled tier? And so this is just a summary of the types of things that we have. And so just an example of what we do. So over in the registered tier, we shift dates. And so we do a random shift backwards for all of our participants. And then in geolocale, we generalize up to US state. We do some generalizations on race and ethnicity so that we obscure very low volume populations in race. And we do the same with respect to sex and gender and sexual orientation, and we don't disclose every little detail about an individual's education. Now, this is registered. This is an expectation that's going to move out to people out in the general public. So we're kind of thinking this is like beta testing. Controlled tier is where we still have a non-human subjects designation, but this is where we put what you're probably more familiar with in terms of the detail with respect to de-identified information. Okay, so this is just a visualization of there's differences here. Now, how we got there, I'm going to walk you through it. Couple things to keep in mind, though. All right, and I like using the European Medicines Agency as an example. One of the things that they did was that when they said we're going to make data available to the public, they allow you to have access to it, but they wanted to ensure that all that data met a certain level of risk. Okay, so they drew a line in the sand with respect to what's an acceptable level of risk. And under their guidance, which came out about 5-6 years ago, they said the risk of re-identification should be no greater than 0.09. This is a really intriguing point in time, because this notion of risk, it's not written into something like HIPAA. It's not written into the common rule in the US, but in Europe, they actually gave an exact number. Now, where they came up with this was they took a look at how the US Centers for Medicare and Medicaid were sharing data publicly. And they use what's called a small cell count threshold. And under that threshold, they say that they don't want information that corresponds to less than 11 individuals being published. And so the EMA saw 11, and they said, well, we want to give a little flexibility with respect to risk, but we want to use the same principles. So they said, we don't want risk to be any greater than 1 in 11. And that was where 0.09 came from. Okay, so in addition to that, one thing that was notable was that they adopted a strategy where if you want to get access, then you have to go through a click-through that you agree to terms of service. And when you go into their terms, one of the things that you will see if you keep clicking through is that you say, I will not seek to re-identify the trial subjects or other individuals from the clinical reports in breach of applicable privacy laws. So in other words, you have to log in, you have to prove who you are, and then you are giving an attestation that you are going to be compliant with their expectations. And in the event that you're not, that gives them the opportunity to pursue damages. So other examples of, so they weren't the first ones to really go down this path with trials data. There was actually a progenitor to this in the United States, which was started by Project DataSphere. And this was a consortia of various pharmaceutical companies that wanted to share failed phase 3 clinical trials data, particularly from oncology-based investigations. And so they wanted to allow people to reuse this data to look at things like the natural etiology of disease. but also do deeper dives into trials that hadn't been combined before. So they partnered with Dream or with Sage and others to support a Dream challenge so that this data could be reused over time. And examples of how this gets reused is there was this great paper that looked at one of the largest natural studies on the progression of prostate cancer in patients across the world. And so there's been a whole series of studies that have been done through the reuse of Project DataSphere. So why do I bring this up? I bring this up because we can't necessarily predict what these resources are going to be used for. And so what de-identification gives you the ability to do is it allows you to make things more widely available without necessarily having to go to an institutional review board to give them an indication of what you're going to do with the data every single time. Okay, so this is a little introduction into like, so who's doing de-identification? Why do we want it? And then I want to give a little bit of a cautionary tale. So one of the concerns that I hear all the time is, well, we really don't want to share data because we're concerned that there's too much of a risk in doing so. And so I like to call this the face that launched 1,000 ships. Now, this face is this person. And if you're not familiar with this person, if you grew up in Massachusetts, you would. This is Bill Weld, who was the governor of the state of Massachusetts. He was actually running as a vice presidential candidate a couple of years ago. And Weld was the poster boy for how re-identification could occur and what the implications could be. This is what's known as the quasi-identifier conundrum. So where this came from was that in the mid-90s, the Clinton administration was really interested in figuring out how to do comparative effectiveness research in healthcare, and so Hillary Clinton took it on herself to do really go around to all the states and say, what type of data would you need in order to do better policy making? Now think about this. This was before HIPAA. This was before really all large-scale health data analytics was taking place. And so the state said, this is the type of stuff we want. And what you're looking at here is what most of you would be familiar with now. This is like standard claims data. But in the claims data, you know, this is basically what became our hospital discharge databases in the US. So this started in the early 90s, and by about mid-90s, you had about 45 out of 50 states compliant with the collection and sharing of all paired claims databases. So this information was collected. Now, why was Weld the poster boy? So Weld was on stage at a university receiving an honorary degree in about 1996, and Weld collapsed while on stage, and nobody knew what happened to him. But what was known was that he went to Massachusetts General Hospital, and at that point, the way in which the state of Massachusetts was sharing information was that they were giving information on the 5-digit zip code of residence, the birth date of the individual, and their gender, as well as when they were approximately admitted to the hospital. So an enterprising young graduate student at MIT said, hey, I think I can find this guy in the hospital discharge databases. So those of you that know LaTanya Sweeney know that she's not bashful, and so she goes off and gets this data, and then she says, well, that's not really the interesting part. The interesting part is that there's fully identified resources that have the exact same demographics on these individuals, and therefore, when I can show that he's the only person with his 5-digit zip, birth date, and gender who was admitted to MGH at that time, then it's pretty clear that this is going to be the governor. Now, the kicker was that the voter registration list that was publicly available that she did this for, this was available for $20, and it was available to anybody who wanted it. And so this is the type of re-identification attack that people really freak out about, right? All right, so a lot of people ask, well, was that a one-off? And then there were a whole series of studies that said, look, if you take common demographics of individuals in the US, then you're going to be able to uniquely represent them for a large portion of the country. Somewhere over 50% of the country is going to be uniquely represented by their 5-digit zip of residence, their birth date, and their gender. Okay, and this type of investigation just set the world on fire. So you pick your favorite feature, and I'm going to give you sets of papers that show how to re-identify people. You see these with demographics, diagnosis codes and rare diseases, health survey responses, laboratory tests. DNA will be a big one, pedigree structures, RNA, proteomes, and the list goes on and on. And I'm also showing like a lot of things that people are interested in for social determinants of health that we're slowly incorporating into these resources. So I think that the notion of DNA for a second, though, requires a little bit of a special conversation because this is where the fear factor really gets ramped up, where this is information that has the potential to disclose relationships between family members, and it's been used in major crime fighting or crime solving cases, such as the discovery of Joseph DeAngelo, who was the Golden State Killer. And he was discovered by the FBI tracking him down through family members and the public dissemination of genomic information that was identified to them, but not identified to him. And they had cold case data where they had his data, his genome, and then they were able to say, oh, well, in this publicly accessible resource, we can find his person's cousin, build up a pedigree around him, and then they just start knocking on doors. Okay, so this is a situation in which it really begs the question of under what conditions could we really claim that this information is ever going to be de-identified? You know, there were subsequent studies. This great study by Yaniv Ehrlich's group showed that this is a type of an attack that can be perpetrated with respect to many individuals simply because of the fact that so much genomic data is now being collected by 23andMe and Ancestry and other organizations where people are getting access to their own genome and then making portions of it publicly available. So, okay, so this is the concern. And so this is where I want to say maybe the world is not as bad as we think it is. And the reason why I say this is that if you give somebody enough time and they extract enough effort and they have enough incentive and they have enough money behind them to do what they're doing, that they're going to find ways to demonstrate that data can be re-identified. And so, for instance, in the situation that I just alluded to with respect to the genomic data, there was a discussion with the group that was performing the forensic genealogy construction, and they said, you know, this is a concern, but this is actually not easy. And just because this has happened for one case, this does not mean that this is going to happen to everybody all the time. So interesting piece of news, it happened, but is this really going to be a problem for everybody moving forward? So, all right, let's take a step back and just really take a look at what's going on with de-identification and what is it, how does it work, and why are we here where we are? All right, so let's look at HIPAA real quick. So HIPAA has a number of ways in which it allows access to data. One, first of all, you can get access to fully identified patient data if you can satisfy two criteria. One, you show that the data has already been collected or it's on the shelf. And then two, you show it's impracticable to go back and get consent from everybody. And this is where you go back to an IRB and you say, I would like a waiver of consent for doing so. Now, if you can't do that easily, then one of the other routes is that you can go and get a limited data set, which is the removal of 16 explicit fields that could potentially be used to identify someone. And then you ensure that the recipient of the data enters into a data use agreement. And that data use agreement is usually a bit Faustian in nature. It says that I'm agreeing to not do anything crazy with this data. I'm only going to use it for whatever I told you I was going to use it for. I will definitely not attempt to re-identify or contact people. Now, the use of identified information here or limited data set, both covered under HIPAA. You violate terms here and the organization can be subject to federal penalties. A lot of people didn't like this. And so when HIPAA came out, there was a big push in the privacy rule to include this de-identified data exemption, which says that you are going to either one, achieve a safe harbor, or two, do a statistical analysis to show that the risk is very small. And if you do this, then you are no longer subject to HIPAA and you are outside the scope of regulation. So how did this happen? So here's what HIPAA says. HIPAA basically says that the information does not identify someone and there's no reasonable basis to believe that they can identify someone. And then under that safe harbor clause, it says, remove 18 types of identifiers and show that you have no actual knowledge that the residual information can identify someone. Now, this was not the first thing that HIPAA put on the table. They actually put the expert determination on the table first, which said, use statistical or scientific principles to show it's a very small risk that an anticipated recipient could identify someone. I love this definition. I love this so much because it is really clear that you are supposed to take into account the capabilities of the users of the data, okay? This was meant to be a risk measure. This is what the Europeans call a privacy impact assessment. And so this concept is actually really highly similar to what you see in regulation like the Europeans' GDPR. And I'm not going to go through all the details of this. It will be in the slides so you can review it afterwards. But basically what it says is that they also talk about how protection should be about for reasonably likely capability. Reasonably likely. Okay, so it doesn't mean that you protect against all possible adversaries all the time. You are supposed to take into account the scenario that you're sharing data into. Okay, so what exactly was these or are these de-identification methods? So safe harbor is just a direct extension of a limited data set. So here's the 16 or a summary of the 16 fields that limited data sets say you need to remove. Okay. And then HIPAA said, hey, remember that re-identification of the governor? What was used in this re-identification? And it said, you used 5-digit zip code, no more 5-digit zip codes. You can share as 3-digit zip code. You know, did you use you used a date of birth? Sorry, no more dates of birth. You can give out the year of birth or the age of the individual, provided they're not in an elderly class, which is going to be a small number of people, let's say. They said anybody over the age of 89. Why did they choose anybody over the age of 89? I don't know, but that's the number they chose. Okay. So there's always questions, though, about how there's this 18th concept listed under HIPAA that said, this one down here, it says the catch-all, any other unique ID characteristic or code. And I always get questions about what is this? And typically we would say this is data that can be used to readily relate individual back to their identity. And I use readily in a term that means like there was an intent here. So concepts that are not explicitly defined in the safe harbor list would be things like, you know, like a prescription number. Or a clinical trial number, or the specific barcode that you might use for tracking an individual's documents during a trial. These were the types of things that the architects of HIPAA said, look, we're not going to explicitly write these down because we can't enumerate all these things. So we're going to leave it up to you to try to figure out, if you know this is unique and this is going to be used to track somebody back to an identified piece of information explicitly, don't share it. Okay, it does not mean that any combination of unique values in a record is necessarily going to rule it out as being de-identified. Okay, secondly, I get a lot of questions about consent. So a lot of people will look at HIPAA and they'll look at the common rule and they'll be like, how does consent play in? It's like, well, it's silent on consent in relation to de-identification. In other words, if you de-identify the record and somebody has not provided consent on this, doesn't matter because consent was not necessary for this purpose. And so this is where things get a little dangerous because since the regulations no longer apply, the data can be reused, it can be licensed, it can be commoditized as the controller of the data sees fit. Okay. I would still say, but it really never hurts to be proactive about what you're doing in terms of having the public know where information is going. And you should at least acknowledge what you are doing. This is where the ethics really comes into play. There is a trust issue that you really need to consider, and that just because you can de-identify and share the data, that does not necessarily mean that the patients really appreciated this aspect. And if they knew that this was happening, they might have some concerns with this. And I do not believe that a conversation with patients about the potential redistribution of data without their consent is really a conversation that has had enough of airplay within the United States. Why do I say this? So things can go wrong, right? Beyond the re-identification that I talked about, that happened before HIPAA, okay? That happened before the privacy rule was in effect. So if you look at what they put into place for protection, we can see some real major challenges with the interpretation of the law. So let's look at safe harbor. So it says, look, you can share the race of the individual, of the patient, which, okay, so if I show you the race of somebody, it doesn't seem so bad, but then let's combine that with ethnicity. Some people might say like we combine these two, but under the Census Bureau's model, they're still separate. You can talk about their sex, but you can also tell me who their insurer is. Doesn't seem so bad yet, right? But you could tell me what job they have. You could tell me what education they've had. You can tell me what their socioeconomic status is. You can tell me how many children they had. You can tell me what language they speak. You can tell me what religion they are. You can tell me how many marriages they've had. You can tell me how many children or college dropouts from whichever marriage they had. The list is going to go on. And this is one of the major criticisms with something like Safe Harbor. It's an exclusionary policy. It says, here's the set of things we don't think you should share because we think there's a potential for re-identification off of them. But it doesn't tell you the things that you can share. And the reason why this is problematic is that, think about this. HIPAA is from the 1990s. There was not massive data sharing at that time. There was no understanding or expectation that the data was going to be shared for the purposes that we're now looking at now. And so we were talking about sharing of data for insurance purposes. It was not an expectation that large-scale electronic medical records were going to be used for anything that you could possibly imagine using them for. So this is one of those times where I say it is very possible that the definition of safe harbor for de-identification is completely antiquated. The other issue with this is that there's a lack of control. So once the data is de-identified, and I mentioned this earlier, HIPAA is no longer involved, which means what's involved? Well, basically nothing. There is no federal oversight at this point. And there's no even requirement to bind recipients to use the data contractually. A lot of us do, right? N3C does, all of us does, but there's no requirement to do so, okay? So what's your alternative? What is it that we should have been thinking of from the very first point when we considered sharing this type of data? Is the expert determination, which said you got to use measurement. You've got to show that the risk is very small, and you need to have an understanding of who you're sharing the data to, because they're not all the same types of users. All right, so what do you do in this type of a situation? So first thing I just want to point out is that there's lots of different ways that you can de-identify data. So you can generalize data to more abstract terms, or you could suppress a feature entirely. You could also randomize values. And a lot of people talk about trying to achieve things like differential privacy and injecting Laplacian noise, or going back to the way I2B2 did this with Gaussian noise. And so, sure, you can do things like this. As I said, all of us, we do randomize to a certain degree. We do a backwards date shift with respect to our records. We go back between -1 and -365 days. You could do what George Ripsack and I designed for the New York City's Clinical Data Research Network, which is recognize that there are potential boundary conditions with shifting backwards, like, COVID didn't exist in the United States before, early 2020. And so you might do a forward shift, at which point you might truncate if you haven't realized the date yet. So if I was to do a forward shift onto April 6, 2023 and show you the data, you would go, that's not possible. And you might be able to winnow down the window of randomization at that point. So what we had designed was this truncate model that said you hold the data out until you hit the date at which it's a real date, or a real potential date. You can also do things like replacing with hashed or encrypted values, right? And if you were to do that, if you had concepts that would be considered sensitive, you would just need to make sure that the distribution of those values are not distinguishable. So you would want to have an indistinguishability argument with respect to the original values. The biggest question, though, that always comes up with de-identification and HIPAA is who is an expert? And this is where we unfortunately are again in a situation where we don't know. So the Office for Civil Rights, which now oversees the privacy rule under HIPAA at the U.S. Department of Health and Human Services, they never define it. There was guidance that they issued back in 2013, and again they punted on it. I would encourage you to go take a look at their guidance. They said there is no specific professional degree or certification program for designating who is an expert at rendering health information de-identified. And from an enforcement perspective, they would review the relevant professional experience and academic training. That's a bit vague. So basically what it means is just about anybody at any place can say that they're an expert. But so like a lot of places are concerned about doing this. So the important thing, though, is that if you can do this and you should do this, what would you document? What do I advocate documenting? First, you need to know who's done the de-identification. It's not sufficient to say that the organization has deemed this as being de-identified, because who made the organization an expert? You want to know what the context of where the data is going to be used. You need to define who the anticipated recipient is. You need to document what it is that you've done the data to protect it, done to the data to protect it. This is in security theory what we call Definetti's theorem. You really want to have a scenario laid out so that you can assess, given everything we've done to the data, do we still think it's protected? We don't want security through obscurity. You want a description of the risk measures that were applied. And this is critical because there's a lot of confusion about what is the right risk measure. Okay. And then there's questions about how do you go about doing risk? Do you do it with respect to every specific record, or do you say, here are the types of information that we think are going to be shared, and from a model-based perspective, using maybe population statistics, we will share the data in a de-identified manner in expectation. And these tend to be much more conservative risk assessments. So when you do risk, when you measure risk, what we've been talking about here in general, what we've seen in the literature a lot is that people tend to say, how distinguishable is the data, or how unique is it? How replicable is it in multiple resources? Like, can I find your information in a voter registration list? And how available is it? But this is actually only one piece of the puzzle. And this is why you've seen why I was alluding to this notion of use agreements or controlled access, because what we've really been seeing is what's the chance that somebody commits a re-identification given that they have committed the attack. But that doesn't mean that they will always commit the attack. And that's where these use agreements and logins and audits, and potentially even if you're in commercial industry, payments for access come into play. So this is why, for instance, identifiability is proportional to all those three. But if you have a situation where you're looking at drug dosing over time, the combination of like time between events may be distinguishable, but the time between events isn't necessarily something that is exploitable by somebody who would receive the data. When you think about it, not everybody has the ability to exploit every little piece of knowledge about somebody's life. So what we did over in All of Us, and what we do in other situations, is we categorize variables by their gross risk. And we categorize it along three lines. One, what's a high risk? What will definitely identify someone that needs to be changed, like their social security number? What's a moderate risk, right? And these are things that have the potential to identify someone, or what we referred to as the quasi-identifiers, like their age or their gender, the date of service or the place of service. And then there are things that are the low risk. And these are the things that we argue that they just do not fail the reasonableness sniff test. And this is something like the amount of copay that was incurred by an individual with respect to their insurance. It's just not something that is reasonably available in a resource that somebody could use for exploitation purposes. So all the while you're doing this, but again, maybe there is somebody who could exploit something like that. Maybe you do have somebody who's coming in from an insurance company and they have had access to information about the payment structure that various patients have had. But again, like this depends on your scenario. Okay, so let's say you now have your residual features, your features that you're going to do protection on. There have been all sorts of de-identify, like anonymization models that have come into play over time. And you know, there is an alphabet soup associated with their development over the last couple decades. What I want to talk about is, I don't want to talk about any of these, because I think that what's happening is that these are all really technical statistical strategies for de-identification, and there's a much bigger picture here. And that on one side you have like an organization that thinks they're doing the good thing by trying to share the data, and they want to be protectors of it. And on the other side, we have real legitimate users, but we are also concerned that people may not do always the right thing. So what this means is that you've got this tension, and you have to realize how to address it. And so on one side, you can say, so what is the incentive strategy for the misuse of this information? Why would they even consider doing this? You know, and then what are the strategies that we can do to try and play out, like how to prevent them from doing something that they shouldn't do? And then how do you put this into procedural action? All right. So what we've done is we've thought about this from a game theoretic perspective. And we think of this in terms of, on one side, we have somebody who wants to share the data, and they are going to gain some type of utility or benefit from sharing the data. What we don't know initially is what the risk incurred in sharing the data is going to be. Now, this is where strategies come into play. So what can we do? We can hold back certain variables. We could generalize demographics, as I've shown you, or perturb statistics. We could apply data use agreements. But then we have to consider, so given who the recipient's going to be, they're going to have all different types of attack strategies that they can use, and they're going to gain some benefit from being successful in their attack. That's their utility, but they're going to end up inducing some negative externality, and that's the risk. And so we could say, so let's look across all the different ways in which somebody who receives the data could exploit the system. And then the one that maximizes their utility, that's the risk that we now plug back into the sharing strategy for this initial sharing strategy for the publisher. And then you can play this out for every strategy that you might consider sharing the data for. So in one, we might generalize the geography and keep the age of the individual highly specific. In another one, we might leave the age of the individual at a much more coarse level and give highly detailed geographic information. Okay. And then for every time we do that, play a different strategy, we look at the risk level that is induced by the attacker. Okay. And then you can play this across all the different strategies by the publisher of the data, and you can choose the one that maximizes the overall benefit while minimizing the risk. And so when you're doing this is why I've said, like, there's a big difference between somebody who's in the public domain and somebody who has been brought into a trusted environment that you have some control over. And so this is exactly what we talk about in this paper that we published a couple of years ago, talking about what are plausible adversarial scenarios and how do you go about defining them and representing them. Basically, what we've done is we've treated it as one big Bayesian network. Most recently, and this is why I don't have a lot of time to go through this, I would encourage you to go take a look at a paper that we just published 2 weeks ago, talking about how exactly did we get to this point with all of us? How did we design one of the tiers in there? Why did we choose to keep certain data generalized and some data in its more specific form? Okay, so this is a paper that just came out in JAMIA. What we do at a high level, I wanted to give a little bit of intuition into this, is we go beyond often uniqueness measures, and we tend to say, so what is the difference in risk in different types of data sharing scenarios? So here's an example of what all of the US states look like in terms of uniqueness of, or expected uniqueness of, individuals who reside in each state, where this is drawn by geocode, age, gender, and race as your quasi-identifier. And so what you're looking at on the left is, if you were to subject it to safe harbor, and we were to use those for identification purposes, there are 50 points here. So we calculated this for every state, and there's variability of identifiability with respect to state. And what you see on the x-axis is how many people are unique, how many people are expected to be in a group of 3 or smaller, 5 or smaller, 10 or smaller. And so what you can see is that the expected rate of uniqueness is low. If this is all that could be used for exploitation, even by being in a group of 10 or smaller, you could see that it's less than 1/3% in expectation for even the worst case scenario. And in most situations, it's below 0.01%. And if you compared that to this notion of the limited data set, or this is your trusted scientific investigator, you have use agreements to the point that says if you're in violation, the federal government can step in. What you can see is that this is orders of magnitude more risky than safe harbor, okay? All right, so how did we go about trying to figure out what's acceptable? So what we would do is we'd say, let's look at the cohort that we're trying to share data on. Let's subject it to something like safe harbor. And say, look, this is something that we were considered to be acceptable if we don't use a crazy amount of quasi-identifiers. And so let's just take a look at what the risk is in that cohort. All right, so let's take a look at how they compare to the population. And then we can start to tune the data in other ways and say, well, is the risk any worse than safe harbor? Yes or no? And if yes, it's unacceptable. And if no, then we consider an alternative. So as an example, this was a data set that we had created for the electronic medical records and genomics network a number of years ago. And all I'm showing is that this was a study on the native electrical conduction of the heart. And we had a couple of patients that were over the age of 89. And we said, are there other ways that we could share this data where we could feel comfortable sharing more detailed age information? And what you can see here is that, this was a special case. We said, could we obscure something like their gender, or could we obscure their race, or could we just put age groups into 2-year bins as opposed to sharing the exact age all the time? And either that, any one of these three would have considered to be acceptable. But you'd have to imagine, right? Like, you don't always want to obscure race, you don't always want to obscure gender, and so just taking a little bit more coarseness with age in this situation seems to be the right way to go. At the same time, I kind of alluded to this with the governor's re-identification. You have to think about all the conditions that need to be satisfied. So if all you do is you have de-identified data on one side of the equation and identified data on another, but you don't have a way to link the two of them, uniqueness is okay. The problem is when you have this linking mechanism. So you really do have to take into account what is being used here. All right, so what I just showed you with some of those statistics was worst case scenarios. This was working under the assumption that the recipient could do anything they wanted with any piece of data. But how do people actually try to exploit the system? Well, often they'll go to things like birth registries or death registries or marriage registries, things that are in the public domain. What's in vogue, if you look in the literature, is everybody just keeps running back to voter registration databases because they're big lists of people that are relatively available. So we went back to the source. This is a number of years ago, but the analysis still holds true. And we were just interested in where all of this data was going and who could do what with it. And so what we found was that at the state level, it was highly varied. And so what we saw was that there were some states that would share all the little naughty bits that you would use for re-identification purposes, and it wouldn't cost you that much money. Like in the state of Illinois, it was like $500 to get like the entire state's voter registration list. But if you went to Wisconsin, you really would only get like the address of residence. You wouldn't even get the age of the individual, and you'd be paying almost $13,000 for that list. So from an adversarial perspective, the risk changes, and I'm just showing you again, looking at limited data sets because it's a much more striking resemblance here. And what you can see is that risk dropped by about a factor of 4 on average when we tried to link it to things like voter registration lists. The more important part was that the economics of the situation changed. So these are just expectations of how many people would be at risk for re-identification. And what we showed was that in certain states like Virginia and South Carolina, there were a decent number of people at risk and it wouldn't cost anything to attack the system. Whereas in states like Wisconsin and West Virginia, there were a lot less people at risk because there wasn't as much information available to exploit, and you'd end up paying a lot of money to do so. So if you wanted to demonstrate where the risks were in the system, you run to certain places and you say there's a problem over here, and all the people over in these other states are okay. Okay, so this is I know I'm going to start wrapping this up in a second, but I wanted to give some further intuition into what's happening next, because this is like a high level intro into what's going on with de-identification. One of the things I wanted to say is that what we're starting to see is there's a push towards federated learning, where each site or multiple sites they hold their data, and instead of sharing individual level records, they'll just share aggregate statistics. And when they share the aggregate statistics, you can then compose models off of the aggregate data. And this is going to prevent inversion, or you're going to mitigate the likelihood that you can get back to the original information that was held by any particular institution. So this is one direction we're seeing. Another is we're starting to see a push towards multi-party computation, where you've got one site says, I want to learn a model, but I don't have any data. And so they'll take their model and they'll encrypt that information and they'll bring it forward. And then the organizer or the holder of the data, they'll encrypt their data, and then you'll allow for some encrypted computation to take place, so that you at no point do you disclose any of the aggregate statistics, even from any particular place. You just end up learning a final model. Right? This is an interesting concept. There are questions around whether or not you trust what the data is that was shared by each site, but the math works out. One of the more intriguing ones is this notion of secured enclaves. And secured enclaves are where you have a tamper-resistant space. Most recently, we've seen this with SGX technology, or software guard extensions from Intel, which basically says you've got tamper-resistant RAM. So you're just going to encrypt all of your data and everything that you want to run with respect to learning off of that data. You send that into like this tamper-resistant environment, decrypt everything, do all the computations you want to run, and then encrypt it and send it back out. And this is like a really intriguing model. I will tell you, the federal government, from a de-identification stance, has absolutely no idea what to do with this. Because the data that goes in there could be fully identified, but the only thing that ever comes out of this thing is de-identified. But during that computation, you have to ask the question, well, were they processing de-identified data? And the answer is definitely no. But if nobody gets to see it, then what was the concern? I was asked to speak for a little bit about synthetic data. This because I know that N3C has gone this route a little bit, and we're heading this route with other programs. And synthetic data has been coming for about a decade now, maybe a little longer. In the health community, it kind of goes back to actually 2002, at least with administrative data, like very simple data. And in the health community, it's sorry, with electronic medical records data, it's not that new. We developed methods for this about 6 years ago with Jimeng Soon's group. And so we've demonstrated how to do synthetic data with data from Mimic as well as from Sutter Health. And basically, this is just your typical, my line is better than your line graph, with the rate of which we can do good predictions with the synthetic data versus the real data on the y-axis. And what you can see is, like, better alignment, better correlation with our method. But there's been an evolution to this over time. And you've seen a lot better training and evaluation methods. You've seen methods that will allow you to incorporate constraints. And then we've seen movement towards longitudinal data as opposed to just static profiles. And let me skip this part. The question, though, with synthetic data is it really all it's cracked up to be? Is it as safe as you really want it to be? And there has been some demonstrations, particularly with imaging data, that suggests that there are potential misapplications of it. So in this great paper by Dong et al., they show, like, here's what a fake or a synthetic record would look like in an imaging or from a facial perspective. And yet what you can see is that it looks highly similar to some of the input data that went into the synthetic data generator in terms of the training data. And so with respect to health data, we have this concern that there's a potential for mimicking the original information. This will happen if you have insufficient training data. There's a potential for membership inference, and that somebody who knows a little bit of knowledge about one of the participants might, or a person in the general public might be able to prove that somebody was in the training data set. Not so much of a concern until you combine it with what's called attribute inference, which says, can I predict new features about someone based on the synthetic data? And so the rubber really meets the road when you combine these two things with each other. So not all synthetic data generators are made equal. And I'll give Chao Yan, who's in the audience, a lot of credit for over the last couple of years building this benchmarking software with friends of ours at Sage and Tempus in the University of Washington on how to evaluate whether or not synthetic EHR data is sufficiently protective with respect to the privacy as well as its utility and use of the data. And so this just came out in Nature Communications about a month or two ago. I'll skip this part, and then I'll just leave you with a closing note. So I was asked to talk about de-identification. I think it's great. I also don't think it's a panacea. I think there's always a risk of re-identification, and risk exists in any setting. So the challenges are really what is an appropriate level of risk, and at the end of the day, having some type of an accountability structure. You should always combine this strategy with some deterrent structure. There should be either use agreements, there should be company, or there should be organizational training here, whoever's sharing the data. And acknowledge that the risk is going to be proportional to the anticipated recipient in terms of their trustworthiness. There's a big difference between putting it out into the public versus sharing it between two organizations like two academic medical centers. And with that, I think I have overstayed my welcome, and I will yield the floor back to you, Joel.
That was a great talk, and I think you've answered most of the questions that have come up in the Q&A. Interesting point about from Johanna Gadir, new brokers that are allowing data to be released without protection, and I think your point that once data is past the sort of past the federal governance, there really aren't rules, and it's kind of the Wild West is something that I think a lot of people don't really appreciate. I also actually thought that the point that you made about systematically evaluating the risk associated with different types of data elements that might superficially appear to be equally bad. Basically, one example might be the date and time when a lab test was carried out. And, yes, it is discoverable if you're the right person, but probably most people wouldn't be able to get into the record. And we don't have time for it, but I think that such topics in terms of discussions of cell sizes, well, which cell sizes? And certainly if you've got, we were involved in releasing data like most people to, Cancer Imaging Archive and other places like that. And so we got sucked into the cell size thing. Okay, so we have our images data, we have our clinical data. And if you look at the cross product of even a modest number of variables, you've got the cell size issue. But if it involves sodium or potassium values, it's in principle, if you actually have access to the EHR or LIS, sure, but not real likely. So I'm not sure. We're over time. This is really fantastic. And I think maybe we should invite you back soon, because I think we've got half an hour to an hour of discussion. Let's see, maybe one question that isn't mine. Is there somebody else who has okay, well, we should wrap things up because it's over time, but really excellent talk and lots of room for discussion. I'm serious. We should actually think of a rewind, because in terms of actionability, if generally people will just sort of adhere to a bunch of rules and hope for the best. So
Yeah, the hope is what bothers me a little bit, because things that have worked in the past aren't necessarily things that are going to work in the future. And that's
Right.
as we make these systems more broadly accessible, I think that we're going to see things that we probably have not encountered in the past. And we're going to have to ask lots of questions about under what conditions we want to share data. But we can talk about that another time.
Right. In what conditions we can share models, and to what
Yeah.
degree a data set generated by a model, say synthetic data, at what point can you retrain a model? If you don't share the model, you share the data set. Can you retrain a model and then start imputing stuff? Lots of interesting questions.
Yep, that's a really big one that we're trying to think through right now. I don't think there's a good answer to it yet.
Right. Okay. Well, thanks. Really appreciate it. Great talk.
Yeah. Thank you.
Okay. Thanks.
It's fun.
Thanks, everybody. Bye-bye.